Hey everybody, it is Mr. Odom, and today we're going to cover lesson 13.3, graphing proportional, a very important word. I'm going to highlight it, proportional, because we've talked about proportions before. So, graphing proportional relationships. Okay, so we start with a quote, and the quote is, if you want to be proud of yourself, then do things in which you can take pride. So I'll pause the video here for a few seconds of reflection and give you some time to think about that quote. And if you want to share some of your thoughts with me, you can. You don't have to, but just, I don't know. I think this is a pretty cool quote. Anyway, the video is going to pause now. Okay, so we're back. Let's get started. Graphing proportional relationships, it's an eighth grade standard, and you need to have a good handle on these definitions. What is direct variation? All right, what is the constant of proportionality? And here's your hint for the constant of proportionality. We just talked about this in a previous lesson. Okay, when you think constant of proportionality, you should be thinking about the slope. Okay, and then what do you need to be able to do? Well, you need to be able to write and graph proportional relationships. Remember, what is a proportion? A proportion is basically two equivalent ratios, right? This is a proportion. Remember, how can I find out? One way is using that cross products property, 2 times 4 equals 1 times 8, okay? Or there's other ways we could tell whether two quantities, two ratios were proportional. All right, let's move on. Your tools, you got to have some tools, or can't get the job done without your tools. All right, so let's go move on here to the next slide. So here is what direct variation is. So when two quantities, and those quantities, since we're moving into algebra, we're going to think algebraically, are variables, x and y. Why do we use x and y? Because we're talking about graphing in this chapter, graphing lines. So it makes sense that we use x and y as our variables. So when x and y are proportional, the relationship between x and y. So this relationship can be represented by what we call the direct variation equation. Okay, and I'm going to highlight this in a different color. The direct variation equation is y equals m times x. And m is called the constant of proportionality. So if you're going to write down, hey, what is the constant of proportionality? Well, it's this variable m in this equation, y equals m times x. All right. And what does the graph of y equals m times x look at? Well, based on the work that we've done, this graph is a line with a slope. Remember, I said that constant of proportionality is a slope of m that passes through the origin. Okay, so let's look at this study tip. In the direct variation equation, m represents the constant of proportionality. That's one thing. It represents the slope of the line, the steepness of the line, and it represents the unit rate. Why is that? So if I have this equation, y equals m times x, and I want to get m all by itself so I can say something about m, what do? I divide both sides by x, so the x's cancel, and I end up with m, the slope, equals y divided by x. Okay? So let's look at the points where we have here. We have this point, 0, 0, and we have this other point that's on this line, y equals m times x, which is m, or 1, and m. Okay? And this point, if I take the coordinates of that point and I put them in this formula, well, the x-coordinate would be 1, the y-coordinate would be m, and notice this is a ratio where my denominator is 1, and we call that, remember, a unit rate. Okay, so this is new stuff. I get it. All right, I understand. That's why I'm going very slow and very deliberately. And I will do this again when I talk about probably this exact same slide during our class period. What do you need to know? You need to be able to, if I give you a line, you need to tell me, does that line show direct variation? What am I asking you to do? Well, does that line have an equation that looks like this, y equals m times x? If it does, then yes, x and y show direct variation because they can be put in an equation that looks like y equals m times x. Another way you can tell is if when you look at the line, if you look at this line, does that line pass through the origin? That's the easiest way to tell. If a line does not pass through the origin, then what happens? Well, then it crosses the y-axis somewhere else. And so it does not show direct variation. X and y are not in a proportional relationship. Okay, so there's a lot of words right there. So I'm going to pause, and I want you to take a screenshot of this. I want you to think about what direct variation is, and I want you to, in your own words, tell me what is direct variation and what is the constant of proportionality. Okay, in your own words. So the video is going to pause now. Okay, so we're back. And let's move on to the next slide. And let's look at a couple examples. So the directions say tell whether x and y are in a proportional relationship. And let's explain our reasoning. And if so, write an equation that represents that proportional relationship. So the first thing we're going to do is, for number one, we want to see, does that line go through the origin? You can clearly see that it doesn't. So in this case, the graph doesn't pass through the origin. So x and y are not in a proportional relationship. That is one of the things that has to happen. The line has to go through the origin. Okay, let's look at number two. This line does go through the origin, and it does go through the origin. So I can say that, I can say that x and y are in a proportional relationship. And the equation y equals 5x, well, where does that come from? Well, here's my point, 0, 0. There's a point right here. 0, 0 is a point on the line. Let me find another point on the line that's easy to work with. How about this one right here? That point is 2, 10. Okay, so I can find the slope, right? M equals y sub 2 minus y sub 1, x sub 2 minus x sub 1. All right, maybe I make this x sub 1, y sub 1. This is x sub 2, y sub 2. And I put these values into the slope formula, and I get 10 minus 0 divided by 2 minus 0, which equals 10 over 2, which equals 5 over 1. So the slope is 5. Well, look at this formula, y equals 5x. Remember, this is in the format y equals m times x, okay? 0, 0 is a point on this line. If I substitute y, so if I have y equals 5x, and I want to substitute 0 in for x, y equals 5 times 0. So that means y equals 0. So the point 0, 0 is on that line. Okay, is the point 2, 10 on that line? Well, we can check. Y equals 5x. So y equals 5 times the x coordinate is 2. So y equals 10. So the point 210 is also on that line. All right. So y equals 5x is the formula for the equation of this line, or I'm sorry, it is the equation of this line. And the slope of this line, the rise over run, is 5 over 1, or 5. Okay, I just said a whole bunch of stuff. Hopefully that wasn't too bad. Let's look at another example. So if we have the tables here, we can also use tables to explain whether x and y are in a proportional relationship. So let's look at number 3. And what am I looking at? The rate of change. Okay, the rate of change. So what is that? The rate of change would be, I take x, which equals 4 over 2, right? So to go from 4 to 2, I have to multiply 4 by 1/2, and I get 2. If I multiply 8 times 1/2, I get 4. If I multiply 12 by 1/2, I get 6. If I multiply 16 by 1/2, I get 8. Okay, so it's constant. Multiplying the x coordinate by 1/2 gives me the y coordinate. So that's why the formula y equals 1/2 x, which follows the format y equals m times x, shows that this x and y are in a proportional relationship. Okay, let's look at number 4. Okay, to go from 1 to 3, I'd have to multiply x times 3. So maybe is a formula y equals 3x. Would that work? Well, I go to the next set of coordinates. To go from 3 to 6, I have to multiply by 2. Well, then I can stop right there. Okay, there is not a constant rate of change, right? To go from 1 to 3 and multiply by 3, to go from 3 to 6 and multiply by 2, to go from 6 to 8, I have to multiply by 8/6, okay? Or, 8/6 or 4/3. So the rate of change is not constant. So x and y in problem number 4 are not in a proportional relationship. All right. So let's look at a word problem. So the cost in dollars for x gigabytes of data on an internet plan is represented by an equation y equals 10x. So we want to graph the equation and interpret the slope. Okay, the equation shows that the slope is 10. So the graph passes through 0, 0 and 1, 10. 1, 10 is a point on that line. You can check it yourself. Substitute 1 for x. 10 times 1 is 10. The y coordinate is 10, so that works. So you can graph it. You draw a line through it. And notice we're talking about gigabytes of data. So it doesn't make sense to talk about negative gigabytes of data. So we're just going to work in the first quadrant where x and y are positive. All right. What does the slope mean? Well, let's look at our units. Here, cost is in dollars. That's the y coordinate. So, and then data used, that's gigabytes. That's the x coordinate. So for 1 gigabyte of data, how much does it cost? $10. That's what the coordinate 110 is telling you. Okay. Whoops. Let me go back. Okay. That's what the coordinate 110 is telling you. And I just messed that up. There we go. Let's get, sorry about that. I'm hitting the wrong buttons on here. There we go. Okay. So you can use a graph to help you decide or determine or answer questions using a graph to interpret what does the slope mean. Remember, the slope is a unit rate. Okay, that's one of the things. So we can figure out how much 1 gigabyte of data is because 10 over 1, which is your slope, is a unit rate as well. All right, let's look at one more. So the weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. Okay, an object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. So we want to write an equation that represents that situation. So we want to use this point to find the slope of the line. Now, the word proportional in this problem means that I can write this formula down. I can use a direct variation equation because I'm telling you that the weight of an object on Titan and the weight of an object on Earth are proportional. Okay, so then I can just plug those values in. I can figure out what the slope would be, and so then I can write a general equation. So now with this equation, I can figure out, hey, well, what if a person weighs 70 pounds on Earth? How much do they weigh on Titan, right? Then you can figure that out using that equation. As a matter of fact, the next problem asks you to do that. All right, it tells you, hey, a chunk of ice that weighs 3.5 pounds on Titan, how much will that weigh on Earth? Okay, so I'm asking you to substitute 3.5 for y, and then you can figure out how much that object weighs on Earth. Okay, so that is section. I'm not going to do this problem. We'll just stick with that one. I'll maybe say that one for later because the video is getting long, but I think you get the general idea. All right. If not, please ask questions in class when I assign you the work to do, and I'll try to help you to understand direct variation. All right. This is Mr. Odom, and I'm out.